Okay, this is concept number 13 notes, which is factoring out the GCF from a polynomial. So the previous section was just finding a GCF. Now we're going to be dealing with polynomials that are being added or subtracted together, and we want to pull a GCF completely out of all of those terms, not just find them. Okay, so it takes it one step further than finding the GCF. Just as a review, okay, simplify this following expression by distributing. We have a monomial times this binomial. Okay, so this is just reviewing the multiplying. 5x squared gets distributed to the 4x to the 4th, which is 20x to the 6th. 5x squared gets multiplied times 3, which is 15x squared. Now, what we're going to actually be doing in this set of notes and in this pretest is working backwards. We're going to take an answer like this and we're going to work backwards to what we just started with. What we just did with the distributing is the best way to check your answers. Okay? We're going to be working backwards from a polynomial to a factored form like this where we have a monomial out front. You're going to need to check your answers by taking that monomial and then distributing it back in to make sure that you get what you actually started with. So if we work backwards from this one, I have 20x to the 6th plus 15x squared. Okay, so we have to first, before I can factor out the GCF, I first just have to know what the GCF is. So we go through that same process that we did when we covered GCFs. I look at my coefficients between 20 and 15. The largest number I can divide evenly between 20 and 15 is 5. So that's the GCF. Then I also have to look at the variables. I have an x to the 6th from my first term. I have an x to the 2nd from my second term. So remember, GCF is the smallest exponent that you have. So it's going to be an x to the 2nd power is the smaller of the two. So our total GCF is a 5x squared. Now, once you figure out what your GCF is, what you are actually doing is taking that GCF, the total of it, so which is here, which is a 5x squared, and you are technically dividing it by each one of these terms. Okay? We're dividing it out of each one of the terms that we originally had. So our GCF is going to go out front of the parentheses, and I am dividing it by each one of the terms. So 20x to the 6th divided by my GCF of 5x squared is a 4. 20 divided by 5 is 4. X to the 6th divided by x squared. Remember your exponent rules. When you are dividing the same base, the shortcut is to subtract the exponents. So it gives me a 4x to the 4th left over. Okay. Then I have a 15x squared. That was my original term. I am dividing out my GCF. So 15 divided by 5 is 3. X squared divided by x squared is just x to the 0 power. It's nothing. They completely cancel. So you don't even have any variables left from this term. All you have is the constant of a 3. So the factored form of it, the GCF goes on the outside of the parentheses. The inside of the parentheses is then what's left over from this division. So I have a 4x to the 4th left over, and I have a positive 3 left over. So my final answer is 5x squared times the quantity of 4x to the 4th plus 3. And again, if you double check your answer, I could distribute this 5x squared into both terms, and I would get exactly what I started with. All right, couple other examples. So I have, in this case, a 12x plus 42y. So I'm trying to factor it out. All I have is a binomial here. So I'm trying to figure out what the GCF is in between them. I have a 12x and a 42y. Now, between 12 and 42, the largest number that I can divide evenly into 12 and into 42 is 6. So my GCF is a 6. Then again, I always look at my variables as well. I have an x with this term and a y with this term. Remember, GCF has to be common to both. Okay? It's the greatest common factor. Well, I don't have any x's that are common to both terms to pull out. I don't have any y's that are common to both. So my GCF is just a 6. I don't have any variables attached to it. Then I have to figure out what's actually left now. Okay? Now that I know what the GCF is, I'm going to factor it out of my original terms. Okay? Remember, factoring is really just dividing. Okay? So I'm now dividing each one of these terms by my GCF of 6. 12x divided by 6. 12 divided by 6 is 2, and you carry along the x. 42y divided by 6. 42 divided by 6 is 7, and you carry along the y. Again, to check your answer, distribute this 6 back in. Make sure that you get exactly what you started with. Okay? 6 times 2x is a 12x. 6 times 7y is a 42y. So since I got exactly what I started with, I know that I pulled that GCF out correctly. In B, 6x squared minus 15x. Okay, again, we're starting with the coefficients. So between 6 and a 15, the most that I can pull out of there evenly, the most that I can divide evenly, is a 3. That's the largest number that will divide evenly into 6 and into 15. Then you have to look at your variables. I have an x squared with my first term. I have an x with this term. Remember, GCF, the variables, as long as they're common to both, you pull out the smallest exponent that you have. So the smallest exponent is an x to the first. Then, now that I know what my GCF is, I have to go back and divide each one of these terms by it. So 6x squared divided by 3x. 6 divided by 3 is 2. X squared divided by x leaves you with one single x, so it's a 2x. Then 15x divided by 3x. 15 divided by 3 is 5. And your x's just cancel because they're the same variable. X to the first divided by another x to the first, they just completely cancel out. So your final answer is 3x. Remember, your GCF goes on the outside, times 2x minus 5. Right, again, if you distribute this back in, you will get exactly what we started with. All right, now in these next two examples, we have trinomials for each of them. Same exact concept. Now I'm looking for a GCF between all three of these. So I need a common factor, the largest factor I have out of 5, 10, and 2. Now in this case, there is no number that divides evenly with 5, 10, and 2. So I don't have a constant with my, or a coefficient with my GCF. That's okay. But you also have to check your variables. So I have an x to the third, I have an x to the second, and I have an x to the first power. So again, GCF, you're pulling out the smallest exponent that you have, which is an x to the first. So my GCF is just an x to the first here. Then I'm dividing that by each one of these terms. The constant, the coefficient is going to stay the same in every single one of these because this is just a 1. 5 divided by 1 is still going to be 5. 10 divided by 1 is still going to be 10. 2 divided by 1 is still going to be 2. The variables are going to change though. I started with an x to the third. I'm dividing out an x to the first, which leaves me with x to the second. Okay, so the variables are going to change in this final answer, but the coefficients will stay the same. All right, last example in this slide. 12x to the fourth plus 4x to the third minus 16x. Again, looking for the greatest common factor. The largest number I can divide evenly into 12, 4, and 16 is a 4. The smallest x that I have within all three of them is an x to the first power, so that's what I'm pulling out front. And then you go through and divide each one of these terms in this trinomial has to get divided by that GCF of 4x. Okay? And then again, you can distribute it back in and make sure that you get exactly what we started with. And then if you do, it's correct. All right, some more examples down here. Factoring out GCF, same thing. So I have a 20x squared y squared. So now I'm just adding in some extra variables on these ones. Minus 4xy. So again, you're starting with the coefficient. The largest number that divides evenly in 20 and 4 is a 4. Now your variables, I have x's and y's, so you have to check them both. Okay? I have an x that shows up in both of the terms. The smaller of the two is an x to the first. I have a y that shows up in both of the terms. The smaller of the two, again, is a y. Now you have to go through and divide. So 20 divided by 4 is 5. X squared divided by x is x. Y squared divided by y is y. When I divide here, 4xy divided by 4xy. Remember, anything divided by itself, these are exactly the same. Anything divided by itself is a 1. So you have to keep a placeholder of a 1 there if your GCF is exactly the same as one of your terms. Right? It's okay if that happens, you just have to make sure you have a placeholder of a 1 there. Next example, 18st, or s squared t to the 5th minus 2s to the 3rd t. Same thing. Greatest common factor is a 2s squared, because that's the smaller of the two variables, and a t to the 1st power. Then you're just dividing it out. 18 divided by 2 is 9. S squared divided by s squared, there's none left. So this term no longer has an s with it because they completely cancel. But your t's are a t to the 5th and a t to the 1st, which gives you a t to the 4th. Then in your second example, or second monomial, 2 divided by 2 is a 1, so it's gone. S to the 3rd divided by s to the 2nd leaves you with an s to the 1st power, and your t's completely cancel. So in this case, all you have left over is an s. That's okay if the other pieces cancel, okay, but you still have to keep that minus s there. In this third example, the only thing you can pull out of each one of these is an x. So that's the only thing that divides out. There is no coefficient that is common to all three of them. So you just pull out an x. These last three examples really are the same thing, but now we're adding in some extra variables. Some of them have an x, y, and a z with them. It's the same process though. You're going to go through the coefficients first, then you're going to go variable by variable. Okay? Remember, in order for it to be included in the GCF, it has to show up in all three of the terms in this case. Okay? It has to show up in every single term in order to be part of the GCF. So if you look at example E here, the 10 comes out of the 50, the 10, and the 70. Then when you start looking through your variables, if I go through the alphabet in alphabetical order, I have an x squared in this term and an x in my third term, but I don't have any x's with this 10y squared, which means I can't have an x as part of my GCF. It has to be common to every single piece. So because of that, I don't have an x that's part of my GCF. Then I check my y's. Well, I only have a y included in the first two terms and not in the third, which means it can't be part of the GCF either. Okay? Same thing with the z. The z is only included in this third term, which means it cannot be part of my GCF. So it's still part of the problem, but it cannot be part of the GCF. Remember, with these, distributing your answer to check your work is extremely important. Okay? Some of these can get really long, and it's very easy to make a mistake on your exponents. If you take that little bit of time to check your work, it'll make your life a lot easier. Okay? So always distribute it back in to double check that you pulled out the right amount of variables. Again, this is your factoring out the GCF, which is concept number 13.